The last lesson in this chapter before the review is lesson 12.7. I better choose a slightly, this marker works a little bit better. Yep, it's a little too thick, but it's certainly, you can see it better. And we're gonna solve rational equations. And you're gonna do a whole lot more of this when you get to Algebra 2. But let's get a good start on it. So, example 1 is going to start us with a simple equation, 6 over x plus 4 equals x over 2. And really, we want to solve for x, but you can see right away this is a ratio, basically. And so all that we need to do is use the cross products property, which you remember. So we're going to do cross products. And so we're going to multiply 6 times 2 equal to x times x plus 4. And you end up with 12 equals x squared plus 4x. And if you set that equal to 0, you'll have x squared plus 4x minus 12 equals 0. You can factor this. X plus 6, x minus 2. And you can see that your answers are either going to be x equals -6 or x equals +2. Okay, not too hard so far. Let's look at, let's see, I'll just do one of the guided practices. Let me just do guided practice 2, and I suggest that you pause the video, do guided practice 2, and then come back and see if you did it correctly. 2 over z plus 5 equals z over 7. Cross products gives me 14 equals z squared plus 5z. If I set equal to 0, I get 0 equals z squared plus 5z minus 14. When I factor, I get z plus 7, z minus 2. So my answers are z equals -7 and z equals +2. All right, let's go on to example number 2. Here's my problem. I have x over x minus 2 plus 1 over 5 equals 2 over x minus 2. Well, clearly I have to come up with a common denominator of some kind. And that common denominator is going to have to go across all 3 of these fractions. How do I deal with that? Well, I can see that my LCD for all 3 fractions is going to be 5 times x minus 2. So, in order to make sure that I take care of all of these fractions, I can multiply the whole thing by 5 times x minus 2 by the LCD. So I'm going to multiply everything by 5 times x minus 2, my LCD. Let's see what happens. X over x minus 2 times my LCD, 5 times x minus 2, plus 1/5 times 5 times x minus 2 equals 2 over x minus 2 times 5 times x minus 2. What this is going to do, by multiplying by the LCD, you're not only going to get, it's going to allow you to clear fractions, and you'll see what I mean. Because right here, I'm able to clear this fraction and be left with just 5x. Here, I can clear this fraction and be just left with x minus 2. And over here, I can clear these out and get left with 10. And this has now turned from a very difficult problem to a quite easy problem, because I now have 6x minus 2 equals 10, 6x equals 12, x equals 2. And I'm done. Now, this is a trick question, and I don't know why they started with a problem. It was a trick question, so I'm going to look for a second one to do with you, because let's see what happens if we substitute in 2 back in. You'll notice that you're going to get 0 in the denominator, and when you do that, you're going to end up with undefined. And of course, you cannot have undefined. And so this is an extraneous solution, and so there is no solution. Okay, so because they gave you such a hard problem, let me give you another one before we leave this and I pause the video. I'm going to do guided practice number 3. Again, if you want to, try it out and then pause the video. So pause the video, try it out, and come back. A over a plus 4 plus 1/3 equals negative 12 over a plus 4. What's my LCD? Well, you can see my LCD is 3 times a plus 4. So I'm going to multiply everything by 3 times a plus 4 to clear all my fractions. So here we go. A over a plus 4 times 3 times a plus 4 plus 1/3 times 3 times a plus 4 equals negative 12 over a plus 4 times 3 times a plus 4. I think my pen is losing ink. I'm going to cancel everything I can, and I'll be left with 3a plus a plus 4 equals negative 36. So 4a equals negative 40, and a equals negative 10. Does this negative 10 work? Actually, it does. And so this is not an extraneous solution. It is a real solution, and I can hold on to it. Okay, that is the end of the first 2 examples of 12.7. And I'm going to stop the video and finish the section in the next video.